Hi everyone, and welcome to our video on the introduction to finding derivatives of logarithmic functions. So when we have a logarithmic function, we're usually dealing with the natural base logarithmic function. So that's our Ln. Okay, so the natural base logarithmic function. So that's our Ln of x. And that's how we say it. So that is the natural log. Okay, so but we usually just say Ln like that of x. I guess. Whoop, let's do that. Of x. Ln of x. Okay, well, it's derivative, so we'll just define it right away. It's derivative, so the most basic ones are right here. So the derivative of Ln of x is 1 over x. And they could put the absolute values on x as well in our derivative. It's still just 1 over x. Okay, so our natural log of the absolute value of x is still just 1 over x. So that's the most basic one. Now, usually we have something that's a little bit more complicated than just x, and that would be using the chain rule to get the derivative. So here we have Ln of u of x. Well, the way I think of it is instantly put this u of x down in the denominator and then look at it for a second and say, oh, let's put its derivative up top. Derivative of u of x right up top. So we just write whatever this is instantly down in the denominator and then its derivative in the numerator. And if it has absolute values like this one, same deal. Okay, so that's how I think of it. Again, instead of writing out the full chain rule, I think in words it can be a little faster and easier. So for instance, let's try this one just in words. We'll do the chain rule shown on the second one. Okay, so it says differentiate. And this one's ready to go. So I'm going to go to blue to say I'm doing the derivative. So the derivative of y with respect to x, dy dx, is equal to, and I see, oh, here's 20x. I'm thinking, oh, throw that down immediately in the denominator and then do its derivative to put in the numerator. So the derivative of 20x is 20. And then afterwards, sometimes these simplify. This one does. Notice the 20s would cancel, so it would be 1 over x. Okay, so that's our derivative of that first one. Okay, so sometimes they simplify nicely and look, it matches the most basic one. That's because there's other rules and logs that we could have used to rewrite that. However, I think this was just as easy. Okay, so let's see number 2 here, and let's rewrite it to where we do a u substitution. So 3 Ln, it is in absolute values, but again, it doesn't really matter. I'm going to say this whole thing is u. And then let's take u to the side. Let me do it in some colors. Okay, so let's take u to the side. And then I can put the absolute value still. Remember, the derivative won't have the absolute values. Okay, so it's not too big of a deal if we forget them on this part, because at the end of the day, they won't be there anymore. All right, but our u is 4x squared minus e to the x. And then our derivative of that u, let's use u prime, is 8x minus e to the x. Okay, so there's the power rule and then the exponential derivative rule. Okay, and then now let's apply the full chain rule. Okay, so I'm doing my derivative, f prime of x. Remember, the 3's just hanging out. Okay, so this is our focus. The 3's just there. And then our rule tells us to put the u in the denominator and then the u prime in the numerator. Okay, so there's my colors. Okay, and then now I'm subbing those back in. So let's keep it one more time in this blue. So we've got 3 and then a bracket, and then they say, oh, u is 4x squared minus e to the x. And they said u prime, or we found u prime is 8x minus e to the x. There we go. And then that's about it. They might distribute, so this 3 is really over 1 currently. So they might distribute that 3 in, but they might not either. So I'm going to say here's our 2 different final answers. They might just say, oh, just keep the 3 and leave your final answer like that. Or distribute the 3 into the numerator, which would give us 24x minus 3e to the x over 4x squared minus e to the x. Okay, so it's one of those. Again, often we don't care. Often we like things factored. Okay, so the top one might be a little better. Okay, but at least this one just shows it as one big fraction instead of something with parentheses. Okay, and also remember, don't do any illegal simplifying. Okay, so it's a subtraction in both numerator and denominator. So you can't take, so I'm going to erase this in a second. So you can't say, oh, these x's should reduce a little bit, so should these 24s and 4s. No, because there's minuses over here. So it wants to do the subtraction first before you do any addition or subtraction. Okay, so careful of that. So remember, only if there's multiplication in numerators and denominators can you simplify. Okay, so let's see 2 others. All right, so let's see these ones. These ones look a little nastier. All right, so let's see, we could deal with them. All right, so here we've got, let's rewrite it. So it's s of t equals 8t ln and then 3t minus 7 to the half power. Okay, so here it is a product. How dare they make us do our product rule? Okay, so that's again always going to be around. Okay, so let's make that note. So we do have to use the product rule on this problem. Okay, and so with our product rule, let's get it set up. So we've got s prime of t. Let's mark it in blue still. So s prime of t, again, that 8's just hanging out waiting. And then I'm going to mark this. Here's our u, here's our v. I'll change the v to pink in a second, or purple. Okay, so we know the product rule is u prime v plus uv prime. All right, and then now we just need to go about and sub those expressions in. Okay, so we've got, let me keep it in blue. So we've got s prime of t is 8. And then now I'm looking at my u prime. Okay, so the derivative of t is 1. And then we'll put all of v in. Okay, so all of that is the ln of 3t minus 7 to the half. There we go. And then we have plus u here. Let me go use parentheses. U is just t that I underlined again. And then now I'm looking at v prime. Okay, so v prime going here. Well, again, it's a natural log, so I'm saying instantly this whole thing should go in the denominator. So 3t minus 7 to the half instantly in the denominator. And then I'm saying the derivative of that should be in the numerator. Okay, so the derivative of this, so I'm looking at this right now, I'm saying the derivative of this, well, that's also a chain rule problem. Okay, so that means the 1/2 would come to the front. And then we'll minus 1 from the power there, so negative 1/2. And then we'll multiply by the derivative of the inside of those parentheses, so times by 3. So the derivative of 3t minus 7 is 3. Okay, and then still we can put that big old bracket down. And then now we're looking to simplify. Okay, so here's something nice that's going to happen though. Okay, so I'm back to black ink because we did our derivative. So 8. This first term, 1 times whatever is 1 times whatever. So it is just ln of 3t minus 7 to the half. And then, well, let's take a look at over here. Okay, so it looks a little nasty right now. Let's just rewrite the t in parentheses. But look at this. This and this. So remember that half power, let me even highlight that in green, that has a negative on it would go down into the denominator. So what's going to happen here, let's rewrite it with a big thing of purple still. I'm going to keep that in purple, is we're going to have 1/2 times 3 left in the numerator. And then this negative 1 here is flipping down, so 3t minus 7 to a positive half power. And then 3t minus 7, this one is still down there. 3t minus 7, also with the half power still on it. Okay, and then we can see, oh, these are the same thing times themselves. That means these powers would add, which makes that 1. Okay, so that now simplifies. Oh, let's get our big bracket. That now simplifies to be s prime of t equals 8, and then ln of 3t minus 7 to the half. And then we have plus. Now, the way I'm going to write this, okay, so this 3 times 1/2, I'm going to rewrite to put it out front. So that would be 3/2, like so. And then the t would be in the numerator. Okay, so just rewriting it. And then all of this is still down in a denominator too. So let's just extend that fraction bar. And we said, oh, it's the same thing times itself, which would mean that the powers would add. 1/2 plus 1/2 is going to be 1. There we go. So it looks something like that. And then for our final step, so they might get a common denominator, but I don't think so. I'm going to leave the 8 out. What I'm going to do is rewrite this half power here back to square root. So that way we would have ln of the square root of 3t minus 7, and then plus 3t over 2 times 3t minus 7. Like that. I think that would be fine. Now, if they want us to get a common denominator, we can. Let me see. Do I have enough room? Okay, so yeah, let's go ahead and do that. Okay, so what currently boxed is should be fine, but I'm going to say if they want a common denominator, this currently has a 1 there, which means both the top and bottom need to get multiplied by this denominator. Okay, so this would have to get multiplied by 2 times 3t minus 7, and the top also, I'm going to just, I can't really put it in good. I'm going to put it just there, I guess, and that will be in the front. Okay, so now let's rewrite it. So s prime of t equals still 8. And then now we've got a big fraction because we have a common denominator. And then in the front of the first term is that 2 times 3t minus 7. And then the natural log of the square root of 3t minus 7. And then plus 3t. Okay, so something like that. And then that's as good as it could possibly get. I don't think they would do anything else afterwards. Okay, so one other thing to talk about. So when you have an ln of whatever, it stays as is. So like this 3t minus 7 down below, or this 3t minus 7 up top, they don't combine with natural logs. So natural logs are stubborn. They like to kind of be left alone most of the time in these expressions. So usually just rewrite it and think, oh, it's fine as is. Let's leave it alone. Okay, I think I'm gonna put a pause. Let's do this one in a different video. Okay, so this one was pretty nasty. Let's take a little break and we'll come back and do that one last one. Okay, so thanks for watching. If you have any questions, please let me know.